One goes to the phone, the other one goes to the cloud. And it can sit outside of the VoIP client. This protocol was deliberately designed to do that it doesn't have to be inside the VoIP client. And other protocols were not designed for that purpose, or to be in that place. This is a little bit like the old PSTN encryption approaches, a decade ago, or 2 decades ago, where you have a phone, a PSTN phone which has a built-in modem, and you call somebody and you talk to them, and then you press the secure button, and the modems train up, and then it starts, and then it's got a codec, and it's got a computer in it, and it sends. It's got a DSP, and now you're talking through a modem with an encrypted digital channel. But before that, you're just talking on a regular PSTN POTS call. And so that's the way secure phones always worked traditionally on the PSTN. And I thought that was a nice approach, and so I'm doing pretty much the same thing here. I'm doing everything through the media plane and separating it from the signaling. It seems to work pretty well. And also, I can deploy it a lot faster this way. I don't have to wait for it to be fully deployed in everybody's signaling layer. Yeah? Yes. It'll be available from a company called Ripcord Networks. If you go to the Zphone Project website and go to partners, customers, here we go. You can see Ripcord Networks here, and you can visit their website. And now I don't know if they have anything on their website now about that bump in the wire, but they're working on the product right now. This is a bunch of companies that are working on products that will use this protocol, that use this SDK. It's in Asterisk. You're supposed to be putting it in FreeSwitch, and within a couple of weeks we'll have it in Akiga. And there's other implementations. There's another open source implementation, and they put it into Twinkle, which is an open source VoIP client that runs on Linux. PGP is planning to put it in their future VoIP products, and Borderware has a kind of a SIP security gateway that they're putting it in. So this is going to be deployed quite a bit. I think that VoIP encryption is not going to be a niche product like it would have been a decade ago. Because while PSTN encryption was only used by a few people that wanted to spend a couple $1,000s on a box for their special needs, VoIP is intrinsically vulnerable in ways that the PSTN is not vulnerable. And so it's going to require all of society, all of everywhere in the world, as they migrate to VoIP, they're going to have to start encrypting VoIP. So it's not really a vertical market thing. It's it's as horizontal as it can get. It's going to become part of the infrastructure. Yeah. Yeah.
How many round trips is negotiation to establish the key?
Well, let's see. How many round trips does it take to establish the key material? Well, there is a probe that just finds out if the other endpoint has it, which I don't know if it's proper to count that as, because maybe the other side doesn't have the protocol, But once you decide that you want to go secure, there is 1, 2, 3. There's this way, and this way. And then there's a confirmation packet that shows you that it's done. So you could say 2 round trips. But you could also argue that you've got the key exchange in 1.5 round trips. Yeah. Well, Skype has some form of encryption in their protocol, but they won't tell anyone how it works. So I don't have an opinion about it. I generally prefer to use encryption that is published. I like to be able to see what a protocol is before I can trust it. In fact, I go a step further. I prefer not to trust encryption unless not only do they have to publish the protocol, they also should publish the source code. And of course, I do publish my source code. I've always published my source code. That's why PGP, in fact, in 1991, I think PGP was one of the first encryption products that published source code. That was 16 years ago. And I kind of started that tradition. Don't trust any encryption product that doesn't publish its source code. Now, I'm not saying there's anything wrong with Skype. Maybe it's perfect. But how do we know that? Yeah, in the back.
Along those lines, how do you trust something like a hardware bump in the wire?
Well, that's a good question. How do you trust a hardware bump in the wire? Well, I'm going to publish my part of it. If some manufacturer takes my SDK and puts it in their hardware, I can't guarantee that that manufacturer is going to publish all their source code because they've got other things in there unrelated to my protocol. But I'm publishing my source code, and I generally try to encourage anyone who wants other people to trust their encryption products to publish their source code. So if you get it from me, you're going to get it with all the source code. And if you want to, download the source code and take a look at it, you can do it right now. Now that I'm no longer doing the demo and I don't care about network congestion, you guys can all download it right now. Yeah.
As I looked at the demonstrations, it looks like a major portion of the security of the product assumes that the two speakers verify the existing.
Yes. Well, let me talk about that. We verified it by comparing the short authentication string, which is a hash of the keying material. But it isn't absolutely necessary to do that because how many people here have never used SSH? See, I would have asked how many people here use SSH, but then I wouldn't have been able to tell how many people hadn't used it. So SSH relies on key continuity. The first time you use SSH to talk to some other machine, there is some exchange of keying material that's cached, and if there's no man in the middle in that first exchange, he can't get in later. And I think that's a great way to do it. Because your typical threat model has it that whoever's going to wiretap you takes an interest in what you're doing at some time later in the relationship you have with the other party. And Zphone uses the same thing. The first time you make contact with the other party, there's an exchange of key material that's cached and used in every subsequent calls. Remember I said all the key material is destroyed at the end of the call? Well, before I destroy it, I hash it. And then I store that hashed version of it. The next time I make a secure call, I do a Diffie-Hellman exchange like I always do. But I also mix in the earlier material from the earlier call and thereby inherit the security properties of the earlier call. So if there was no man in the middle in the first call, there can't be one in this call. In fact, if you talk to someone 100 times over the course of a year and you never check the short authentication string because you're lazy, I mean, I usually don't check it, Oops, I shouldn't have said that. Now the wiretappers will know that they can wiretap me. But I frequently don't check it. And so you could just not check it at all and call somebody 100 times over the course of a year. But after a whole year of talking to that person, talking about the weather and about other innocent things that you don't really care if anyone's wiretapping you, one day you're going to talk about something sensitive, and on that day you're going to say, I think we'll check the short authentication string today. And so you check it, and it matches. So that proves there's no man in the middle on that call. But it also retroactively proves that there never was a man in the middle all the way back to the first time you talked to that other party. And that's a really nice security property. It's kind of like never flossing your teeth except the morning you go to the dentist. Where you can wash away your sins of the past year and redeem your dental hygiene. So just check it once when it matters. And it doesn't matter how many times you checked it before. So I predict that hardly anyone will ever check the short authentication string, and who cares? Because most of the time you're talking about the weather. But when you're talking about something important, just check it once, and it will retroactively cover the earlier calls, and it'll cover the future calls, because you don't have to check it next time. I got a call on somebody else. Yes, in the back there. Okay, are there any software patents? Actually, this is an interesting question because I found a way. I hate software patents. I don't know if you followed this, but back in the 90s, PGP was using the RSA algorithm, and that created problems for PGP, and because the RSA algorithm was patented. I really hate software patents, but I found a way to use a software patent for good instead of evil. And here's what I do. I think that, think about what happened in the 1990s during the crypto wars. The government in the early 90s introduced the Clipper chip, which was an encryption device that they hoped that companies that make secure phones would put into their phones. And in this device would be an encryption key that the government had a copy of in a vast government database. Every chip had a different key. And they would store this database and keep it around for wiretap purposes. Oddly enough, the Clipper chip was not politically popular. And so it never made it in the market. People didn't like using phones that were wiretap friendly. So I thought about this, and I thought, at least we knew which phones had the Clipper chip. In fact, actually, I can only think of one. It was the AT&T 3600, which was first manufactured without the Clipper chip. In fact, I just used plain old DES. But then the NSA got all upset about it and offered to buy up all the ones that had used the DES chips and replace them with Clipper chips. And that's what they did. And so the AT&T 3600 was available after that with Clipper chips in it. But at least you knew that this phone here, made by AT&T, this model phone, this had a wiretap chip in it. And maybe some other secure phone didn't. And I think that's a good thing, because I don't really care which phones have Clipper chips. I'm just going to choose, I want to let market forces decide. I think people will prefer to buy the ones that don't have wiretap-friendly chips. And so what I did with my protocol is I made a special flag in the protocol, in the packet, the confirm packet at the end of the protocol, that says whether the other side has made a copy of the session key and for, to send it to the government or whatever you want to send, made a copy of it and stored it somewhere other than that what was needed for encrypting the call. Because, some businesses have a legitimate need to monitor calls. Maybe a stock brokerage, for example, might record your call for the benefit of preventing insider trading or keeping their stockbrokers honest, or maybe you work in a high security area protecting, nuclear weapons or something, and you just, there's a need for them to monitor your calls, and that's fine. And I have a flag in the protocol that says that, okay, I'm sending you this packet with this flag, confessing that I have taken the session key and given it to someone else so that it could be wiretapped, or maybe just recorded and, and decrypted later.